Hi, this is Tony Cowie from Team M Square, and we're engineer Janie Purdy and mathematicians Valdez Mosley and myself. I'll be sharing our prototype design, how we arrived at our final solution, the materials we used to construct our prototypes, and the construction of my prototype. I will also share our foundational calculations. We started brainstorming prototype design ideas by researching what was already out there. Our initial search led to this first sketch, which included a funnel system for adding sugar solution and an inverted graduated cylinder system to capture carbon dioxide. We abandoned this idea because of the inefficient heat source. Our second design alleviated the heating issue by including a water jacket, but generated discussion around draining the ethanol and the composition of the reactor solution. We conducted research on sodium and calcium alginate, methods of immobilization, and yeast activation in order to finalize our design. Our final prototype design you see here includes a bioreactor, our carbon dioxide capture tank, and our ethanol capture tank. In the remaining slides, I'll be reviewing each part in greater detail. This is our bioreactor. The bioreactor is made from a 1-gallon plastic bottle. 4 holes were cut, 3 in the cap and 1 near the base. We used 2 glass tubes, 1 glued in the hole on the bottom and 1 in the cap. We attached rubber tubing to each of these tubes and controlled egress using tube clamps. Next, we added the thermometer and finished with a plastic funnel with a rubber stopper. We used a cooking pan for our water jacket. A hot glue gun was utilized for attaching items and sealing holes. This is our carbon dioxide capture tank. Our tank was fashioned from a 1-gallon plastic bottle marked with 100 milliliter increments. The tube from the bioreactor was attached at the bottom of the plastic bottle. The water filled the plastic bottle was inverted in a plastic tray half filled with water. Our ethanol capture tank, we utilized a 1-gallon plastic bottle and inserted the tube from the bioreactor. With regards to our calculations, we created a sugar solution using the given information from Dr. Wells. The yeast calculations gave us the greatest challenge. We used the Alcatech ratio to convert ethanol from liters to grams by setting up this proportion and solving. Since no one brought home a scale, we needed to convert the amount of grams to teaspoons as best as we could using this ratio we found on the internet in order to determine that we had to have this many teaspoons of yeast. With regards to our sodium alginate mixture, we struggled with calculating the amount of sodium alginate we would use. However, Madden 2007 suggested this ratio, which led to this proportion and this final calculation for the amount of sodium alginate that we should mix with our yeast. Finally, using Dr. Wells's information in order to determine the size of our calcium alginate screen, we used this ratio to determine this proportion and get at this calculation. However, since none of us were using a container large enough, we decided to simply go with calcium alginate beads.